In this question, there are two bipolar transistors and these two are matched transistors, and for both the transistors beta is very high. The current gain is very high so that their base currents are negligible. Means they will have finite collector current and emitter current, but since beta is very high, applying IC equal to beta IB, IC is finite, beta is very high, so IB can be negligible. I1 is given as the emitter current of first transistor, this is given as 1 milliampere, and I2 is given as I2 has to be 100 microampere. Then we have to find out the value of resistance R2, and the thermal voltage KT by Q is given as 26 millivolt. Okay, here current is given, I2 is given. Okay, so this is obvious that for finding out the value of whether resistance R1 or R2, we have to apply KVL. So current is given, so the voltage across resistance we will write, when we will apply KVL, voltage across resistance we will write I into R. Normally in DC analysis, the voltage across VBE we take it as 0.7 volt. In a transistor, this is B, this is E, this is NPN transistor, and we assume that this junction is forward wise. If it is not in cutoff mode, this diode is in forward wise mode. So the voltage across, when the transistor is on, voltage across this diode will be 0.7 volt in DC analysis, or when the range of current is in milliampere, or current is relatively large. But when the current through diode is sufficiently small, we cannot take the VBE or VD on equal to 0.7 volt. Okay, when the voltage across diode or the current through diode is very low, VD on, we cannot take VD on is equal to 0.7 volt. Instead, we will apply this formula. The current through diode, this is equal to reverse saturation current into E to power VD divided by VT minus 1. Normally this quantity is very large as compared to 1, so ID can be approximated as IS into E to power VT divided by, here we have eta VT, okay, VT divided by VT, and VT is equal to KT divided by Q, which is given as 26 millivolt. So this is, since this is given in question, KT divided by Q, so this is also a hint that you have to apply the voltage and current will be related by this formula. Voltage across diode will not be constant as 0.7 volt. Okay, this is the exact relationship between diode voltage and diode current based on the graph. This is the graph. Okay, and when the current is sufficiently large, then the diode voltage can be approximated as 0.7 volt, but in this region the diode voltage will not be 0.7 volt. Okay, so in this question VBE is not given as 0.7 volt, so we will apply exact relationship between diode voltage and diode current. What will be the diode voltage? If we will take Ln, diode voltage will be VT Ln ID divided by reverse saturation current of diode. Okay, so in this NPN transistor we can assume that here a diode is connected. This is forward wise diode. Okay, so applying KVL in this branch, in this loop, 6 volt will be equal to voltage drop across resistance R1. So the current through resistance R1 is I1, so I1 R1. Okay, and here voltage drop will be Vd equal to Vt ln. The current is I1 here because this current is I1, this current is I1, and in this branch the two base currents are negligible, so this current will be negligible. So here also current will be I1. So ln I1 divided by IS1. And since the two transistors are matched, the reverse saturation current for this diode for the both the transistor will be same. So let us assume this is IS. This will be 0. Applying KVL in this loop, this is the second loop for R2. Again 6 volt minus I1 R1. Okay, then transistor 2 thermal voltage and reverse saturation current will be same, but in this transistor current is I2. So here we will write I2 divided by IS equal to, okay, so this is voltage drop across the diode, and voltage drop across R2 will be I2 into R2 minus I2 R2 will be equal to 0. So equating both the two equations, 6 volt and 6 volt will be cancelled. Okay. Subtracting these two equations, 6 volt I1 R1 will be cancelled. So here we will have I2 R2 equal to Vt ln I1 by Is minus Vt ln I2 by Is. This will be Vt ln I1 by Is divided by I2 by Is. I1 by Is divided by I2 by Is. So Is will be cancelled. Vt is 26 millivolt ln I1 is 1 milliampere and I2 is 100 microampere. So this will give you 26 millivolt ln 10. 26 into 2.3025. This is I2 R2 and I2 is 100 microampere. So R2 will be 26 into 2.3025 divided by, since this is in millivolt, so if we will take current in milliampere, 100 microampere is 0.1 milliampere. Milli will be cancelled, and the value of resistance you will get, the unit of resistance will be ohm. So this value will be 226. This will give you approximately 598 ohm. This is a rectifier circuit in which the load current is assumed to be constant at 1 ampere. The load may be such that it has a high value of inductor which will make the load current as constant. So load current is constant at 1 ampere, and input voltage is this is a triangular wave of amplitude 10 volt and time period is equal to 1 millisecond. So this distance, this will be 1 millisecond. Whenever diode will be conducting, what will be the mechanism of this circuit? Whenever diode is conducting, the capacitor voltage or the output voltage will be equal to input voltage without any delay, because in this circuit there is no resistance in this circuit, resistance equal to 0, capacitance is finite, but the time constant is R into C, which is 0. So if time constant of this circuit is 0, this circuit will be very fast. In fact, this will be infinite. This circuit will be very fast. So there will be no delay between the capacitor voltage and the input voltage. Whenever diode is connected, the capacitor voltage will follow the input voltage as it is happening between this interval. Okay, so in this question we have to find out the value of this ripple. We have to find out this ripple, mu equal to what. Okay, so to solve this question, let us first analyze the mechanism of this circuit. Let us start from this point. At this point, input voltage is 10 volt and output voltage, it has also its peak. So the peak value of output voltage will also be 10 volt. After this point, the capacitor will be at this point, the capacitor voltage will be 10 volt. But after this point, the input voltage decreases very rapidly from 10 volt towards 0. So but the capacitance is very high, so the rate of decrease of capacitor voltage will depend upon the load current. Okay, so what will happen after this point? The rate of decrease of capacitor voltage is not high, but the rate of decrease of input voltage is very high. So after this point, input voltage will be less than capacitor voltage, and whenever input voltage is less than capacitor voltage, this is at capacitor, the voltage across diode is input voltage minus capacitor voltage. So the diode will be reverse wise, this will be open circuited. So the circuit will be this: a current source with a initially charged capacitor. So at this point, the capacitor voltage is 10 volt and the load is drawing constant current, so the capacitor voltage will decrease. And in the network we have studied that decrease in capacitor voltage, delta Vc is equal to I by C into delta T. Okay, so from this point to this point, the circuit will look like capacitor with a constant current source, and the decrease in capacitor voltage will be given by this formula. At this point, what will happen? At this point, the capacitor voltage, starting from this point, the input voltage decreased very rapidly. So first input voltage goes to 0, then negative. From this point to this point, if you compare capacitor voltage with input voltage, at all the points of time, the capacitor voltage is greater than the input voltage, and whenever capacitor voltage is greater than input voltage, diode will be reversed wise, this will be open circuited. But at this point, the capacitor voltage and input voltage, these two became equal, and after this point, the rate of increase of input voltage is greater than, okay, so after this point, input voltage will become greater than the capacitor voltage. If capacitor voltage continues to decrease, let's say it continues to decrease, or better first find out the reason why capacitor voltage is decreasing, because the input voltage is less than capacitor voltage. If input voltage is less than capacitor voltage, then the diode is open circuited, then capacitor has to supply the load current, that's why capacitor voltage is decreasing. But after this point, or at this point, input voltage equals capacitor voltage, or after this point, if capacitor voltage keeps decreasing and input voltage is increasing, so input voltage will become greater than capacitor volt, and the diode will be, now the diode will be on, and if diode is on, capacitor voltage has to be equal to input voltage. So that's why after this point the capacitor voltage is following the input voltage. Okay, so till the time input voltage is increasing, capacitor voltage will follow the input voltage, and again from this point input voltage is decreasing. So after this point input voltage will become less than the capacitor voltage, then again diode will be open circuited and capacitor will have to supply the load current. So this is the mechanism. So in this span of time we have charging of capacitor, and in this span of time the remaining time from the 1 millisecond, this is discharging of capacitor. So let's say this interval of time is t naught, and the total interval is capital T, that is 1 millisecond. So the charging interval will be, this charging interval will be t minus t naught, and the decrease in capacitor voltage will be, this is the decrease in capacitor voltage, and also the increase in capacitor voltage is also the same. We have formula for decrease in capacitor voltage. In this range the decrease in capacitor voltage is nothing but U, current is, let's say current is 1 ampere, let it be C only, and this duration is t naught. So ripple will be given by 1 by C into t naught. Again this height is also U, so this U will be the slope of this line into the time interval. So this time interval is nothing but t minus t naught. This time interval is nothing but, the charging time is t minus t naught. So U will be given as the time interval into slope. What is the slope of this line? Since this is the capacitor voltage, and in this interval capacitor voltage is following the input voltage, so the slope here will be same as the slope of input voltage. So what is the slope of this line? The change in voltage is 10 plus 10, the peak is 10 volt, 20 volt, and change in time is half of time period, that is t by 2. So the slope will be change in voltage divided by change in time. Okay, so equation 1 and equation 2 are same. I mean 1 by C into t naught, this will be equal to t minus t naught into 40 by t. This is 1 by C into t naught equal to 40 minus 40 t naught divided by t. So t naught into 1 by C plus 40 by t is equal to 40. So t naught is 40 divided by 1 by C plus 40 divided by t. Now put the value of t naught here, we will get U. U is equal to 1 by C into t naught. Okay, so 1 by C into t naught is, okay, multiply with C, we will get 40 divided by 1 plus 40 C divided by t. So this will give you 40 divided by 1 plus 40 into C is 475 into 10 to power minus 6 divided by t is 10 to power minus 3. So this will make 10 to power minus 3. So this will give you exactly 2 ampere. So the peak to peak ripple U is equal to 2 ampere will be the answer. This is a positive feedback circuit of operational amplifier, where the V plus, this will depend upon the output voltage. If output voltage is V naught, so V plus is V plus is equal to V naught into 1. Output voltage will be divided into 4 kilo ohm and 1 kilo ohm, and V plus will be voltage across 1 kilo ohm. So V plus will be V naught into 1 kilo ohm divided by 1 plus 4. This will be V naught by 5. And the saturated voltages are 10 volt and minus 10 volt. Okay. And since we have a positive feedback, so the output of op amp will be, this will be either plus 10 volt or minus 10 volt. Okay, so let's say this voltage is plus 10 volt, and let's say we don't know whether the diode will be broken down or not. So let's say this voltage is 10 volt. Now the voltage across diode will be this Zener diode. This will be in forward bias mode, and if this is ideal, if this is an ideal Zener diode in forward mode, this is the operation of Zener diode in forward mode is same as the normal diode. So if it is an ideal diode, the voltage across this diode will be 0, or 0 just greater than 0 voltage will be required to turn it on. So if this is 10 volt, the voltage across this Zener diode is equal to 10 volt, and the Zener diode, it is given in question that the Zener diode clamps the voltage at 5 volt. It means the breakdown voltage of the Zener diode Vz is equal to 5 volt, and the output voltage is greater than 10 volt. So this Zener diode will be broken down, and it will behave as the constant voltage source of 5 volt. Okay, so this voltage will be at 5 volt, this voltage is at 10 volt, and this is at 5 volt. So accordingly, here the current will be 10 minus 5 divided by 470k. Okay, this current will flow here. Okay, and accordingly the current will, this will be in forward mode, current will flow in this direction. Similarly, when the output voltage will try to become minus 10 volt, this diode will be broken down, and the output voltage will be minus 5 volt. In forward, when the output of op amp is 10 volt, this Zener diode will be broken down, output voltage will be 5 volt, this will be in forward mode. So the overall we can say the output voltage will be either 5 volt or minus 5 volt. So V plus will be, this is 5 or minus 5, so this will be plus 5 by 5 or minus 5 by 5. It means V plus will be equal to 1 volt or minus 1 volt. Okay. Now in question this is given that the switch is initially closed. So if it is closed initially, okay, so V minus will be at, if this is short, V minus will be at 10 volt. So if V minus is equal to 10 volt, not minus 10 volt, and V plus may be 1 volt or minus 1 volt, in either case V minus is greater than V plus. So if V minus is greater than V plus, the output voltage will try to be minus 10 volt, and Zener diode will clamp it to V naught equal to minus 5 volt. So initially the output voltage will be minus 5 volt, and the voltage of non-inverting terminal will be minus 5 divided by 5. So this voltage will be minus 1 volt. Okay, so V plus is, initially V plus is minus 1 volt, output voltage is minus 5 volt, and V minus is the potential of this inverting terminal is 10 volt. Okay, 10 volt is V minus is greater than V plus, so output voltage will be negative. Now when this switch is open circuited, initially when this switch was short circuited, the voltage across capacitor was, let's say this is Vc, this voltage was 0 due to this short circuit, and current continued to flow through this path. When this switch is open circuited, now current will flow through this path and capacitor will start charging. So let us first find out the voltage of inverting terminal with respect to capacitor voltage. So if we move from this point to this point, we will have a gain of 20 volt. 20 volt minus drop of capacitor voltage. We moved at this point, and at this point we have if you will move from this point to this point, we will have a gain of V minus 10 volt. This means V minus plus 10 volt plus V minus plus 10 volt, or better than applying KVL is, we can simply write down V minus as potential of this point is 10 volt minus Vc. V minus will be equal to 10 volt minus Vc when switch is open circuited. Okay, and what will happen in steady state? In steady state, there will be no current from the capacitor, there will be no current from the resistance also, because there is only one path, that is through capacitor, and in steady state capacitor will not allow any current, so there will be no current through the resistance. And what will be the capacitor voltage? If there is no current, the voltage drop across resistance will be 0, so the capacitor voltage will be charged to 20 volt in steady state. So in a steady state, what will happen? If it goes to a steady state this way, V minus will be 10 minus capacitor voltage is 20 volt. This will be minus 10 volt. So we will say the V minus, this will change from 10 volt to minus 10 volt, and in between what will happen? V plus is constant at minus 1 volt. Okay, minus 10 volt plus 10 volt, 0 volt, and let's say this is minus 1 volt. So V minus is moving from plus 10 volt to minus 10 volt, and V plus is at minus 1 volt. So at this point V minus will become less than V plus. V minus will become less than V plus, and at that time the op amp will switch its output voltage. Okay, so V minus is going from plus 10 volt to minus 10 volt, and when V minus will be equal to minus 1 volt, when it will be crossing minus 1 volt, the op amp will switch its voltage. So we have to find out, in this question we have to find out the instant of time t1 when the V minus will become minus 1 volt from 10 volt. Okay, and since this voltage will change according to the RC circuit, that is a first order circuit, so Vt is given as V infinity minus V naught into e to power minus delta t divided by tau. This we have studied in network DC transient circuit. V infinity is the steady state voltage. The steady state voltage of V minus is minus 10 volt, minus 10. V naught is initial voltage, this is 10 into e to power minus delta t divided by tau, where delta t is absolute time minus the time of transient. So the time of transient T naught is equal to 0. The switch is opened at T equal to 0. And Vt is, this voltage is, we have to find out the time T when Vt will be minus 1 volt. So here we will put minus 1 volt. So minus 1 will be equal to minus 10 plus 20 into e to power t divided by tau. So tau will be equal to ln 20 divided by, sorry, t will be equal to tau ln 20 divided by 9, and tau is equal to r into c. This is RC ln 20 by 9. R is equal to 10 kilo ohm and C is equal to, the value of C is, this is 100 microfarad. So 10 kilo ohm 10 to power 4, 100 microfarad is 10 to power minus 6 into ln 20 by 9 second. This is 0.798 second. Okay. This is approximately 0.8 second.